Okay, and lastly, let's look at something we call an aggregation. This is the most complex thing that we'll look at in this week's session. Basically, we're going to take our data analysis one step further from where we left it last week. Last week, you may remember we were able to collect a list or a set of values and then be able to do more sophisticated analysis on it than we had been able to do in the prior week. In the week 3, we did a sum and a count, and we were able to use those to derive an average. In the following session last week, we looked at a list or a set of values and asked, how can we analyze these values in multiple ways? Can we derive the sum, the len, the average, the median? Well, now we're going to go even further. We're going to do something called an aggregation. And if I were to ask you to write a program to count the number of times each state appears in the dictionary, what would you do? How could you do it? You might want to pause this and think about how you might do it. I want to count each state. I want to be able to say that there are 3 New Yorks, 2 New Jerseys, 2 Pennsylvanias. How would I do that? Now, the answer is there are always multiple ways to do things usually, but basically what we want to do is use a dictionary for this purpose, because a dictionary would be the simplest, most direct way to aggregate a count or a sum. In other words, I might ask 2 questions of this data. How many times does each state appear? In other words, what is the distribution of these companies by state? We would end up saying that there are 3 companies from New York, 2 from New Jersey, 2 from Pennsylvania. Or I might want to ask, what is the revenue by state? If this was some sort of file that showed us our different companies and the revenue that occurred with each company, we might be interested in knowing which state saw the best revenue. That might help us focus our efforts on one state or another. So we might want to ask a question like that. The 2 questions are, what is our distribution of companies among the states? In other words, how many instances of each state are there? For that, we would use something called a counting dictionary. And we might also ask, what is the revenue by state? So which state saw the most revenue and which state saw the least revenue? This would be calling a summing. We would use a summing dictionary for this purpose, and we might call it a summing aggregation. A counting aggregation and a summing aggregation are really quite common. They're definitely a very basic and core function that you would find in a database query, because they have things like sum and count that allow you to aggregate in that way. And we call it an aggregation. Of course, we're calling it an aggregation because we're aggregating values under a unique key. How many New Yorks, how many New Jerseys, or how much for New York, how much for New Jersey. So we're summing up by key. We call that an aggregation. And I'm going to show you how that's done in a dictionary. Now, this gives away a lot from the homework, but it is the most complicated thing that we'll look at this week, and so I want to make it really clear how it's supposed to be done. When we use a state count, for example, if we're counting up the number of instances of each state, then what we're going to want to end up with is some sort of dictionary that has a unique key for the state, and then the number of times that state was found. New Jersey, and we'll do that for each of these. Each state and the number of times that state was found. So the question is, how could we build up a dictionary in this way? What you want to keep away from is the concept that we might have to loop through the data source more than once. We certainly don't want to do that. We never want to loop through the data source more than once, because if we're looping through it and we can see all of it, we should be able to aggregate or put together what we want from looping through it once. If we need to use intermediate structures to do our purpose, whatever it is we need to do, we would just put it into those structures. By that I mean lists, sets, or dictionaries. But as it turns out, an aggregating dictionary, that is a counting dictionary or a summing dictionary, can be done in one pass of the data. The way we're going to do it is we're going to use the dictionary, we're going to use the unique key as the key, and then we're going to basically add 1 to the value for that key every time the state reoccurs. In other words, think about what we're going to do if we can only loop through the data once. And as we loop through the data once, we're able to be counting everything that we see so that we end up with a dictionary like this one. We would be keeping a running count of the dictionary as we looped through the data. I'm sorry, a running count of each state as we loop through the data, which means that after the first line, we would have a dictionary that says Pennsylvania is 1. After the second line, we should see a dictionary that has Pennsylvania as 1 and New Jersey as 1. After the third one, we should see Pennsylvania is 1 and New Jersey is 2. And keep in mind, I'm talking about the same dictionary. I'm saying that if we were going to build up an aggregation of counts for each state using a dictionary and looping through the data just once, we're going to want our dictionary to look like this at each stage. One dictionary, it would look like this after the first line. It would look like this after the second line. It would look like this after the third line. It would, in fact, update itself with the correct additional count as we loop through the data. So let's do that now. Basically, what we want to do is add to the dictionary. If the state is there, we might want to make it equal to 1. Or maybe what we want to do is add 1 to the state for that dictionary. In fact, that is what we want to do. I'm going to abbreviate this to SC. And then I'm going to, this is just in the interest of saving space, I can say SC state equals SC state plus 1. Now what that's doing is saying take the value for this state, add 1 to it, and then assign it back to the key for that state. In other words, you understand that on the right side of the equal sign, we are reading the value for that state. And on the left side, we are assigning the value for this state. Now, this is one of the reasons that this can seem so complicated, although it's not that complicated. We are basically saying, take the value for this state, whatever state it is, it could be New York, for example, take the value for this state, add 1 to it, and then assign it back to as the value for that state. So take the value for this state, add 1 to it, and then assign that new value back to the, let's say, to the dict for this key. In other words, we're updating the value for the state, whatever the state might be, New York. We're saying take the current value for New York and add 1 to it, which of course, as we're looping through the data, that's what we should do. We should add 1 to the value for Pennsylvania. We should add 1 to the value for New Jersey. We should add 1 to the value for New Jersey. That'll be 2 for New Jersey. Then 1 for New York. Then 2 for New York. Then 2 for Pennsylvania. Then 3 for New York. We should be adding, and this is a way to do it. But there's going to be a problem. Let's see what happens if we run this. Maybe you've already guessed, maybe not. Key error PA. Now, we didn't look at the exception very closely the last time we highlighted it. But when it says key error, I think you know what that means, or you may remember from the video. A key error means you asked Python to read the value for a key that doesn't yet exist. It's not in the dictionary yet. And what we're seeing to the right of the colon there is PA. PA is saying, I couldn't find the PA key. Now looking back at the data, you can see PA is the very first line. So ostensibly what it seems to be is that this program failed on the very first line. Why did it fail? Well, that's a really good question. And if you'd like to pause the video and think about it, keep in mind that we're on the very first line, that the problem line is right here, as it says in the error here, and that the problem is we asked Python to read the PA key, but it doesn't exist yet. Go ahead and pause the video and see if you can make sense as to why we got a key error. All right, here it is. We got a key error because we asked the dictionary for the PA key. But if we're at the very first line, of the file, which we are, and we could put in a print statement to prove that, if we're at the very first line, what's in the dictionary? If we've only just now split the very first line and we're on line 8 attempting to add 1 to the value for PA, what's in the dictionary? The answer is there's nothing in the dictionary. We haven't even added to the dictionary yet. So the problem with this line as it is right now, it's going to be useful to us, but the problem with it right now is that it's saying take the value for PA, add 1 to it, and then assign it back to as the key for PA. In other words, if PA was 1, then we'll add 1 to it, we'll get 2, we'll assign it back to the key for PA. Problem is, it's not there yet. There is no key for PA. So we have to differentiate between the time that we first encounter a key and the time that is the second time or subsequent time that we encounter a key. In other words, this is okay. This would be fine if the PA key already existed. If the PA key was, let's say, 1 or 2, let's say it was 2, if the PA key was associated with the value 2, then this would take the value 2, add 1 to it, and assign it back to the key PA. And that would be great. PA key would now be 3, and that would work perfectly. The problem is if PA is new, if it's a new key, then we can't add to it until we've already established it. So we can do a simple thing. And here's the question that you might want to pause the video again and see if you have the answer to. The question is this: how do we check to see if a key is in the dictionary? Go ahead and pause and see if you can remember. How do we check to see if a key is in the dictionary? Got it? We use the in operator. If state in SC, then go ahead and do it. Otherwise, well, actually, this would be even better. If the state is not in SC, then perhaps what we should do is say SC state equals 0. And then, once we've established it, we could go ahead and add 1 to it. So all we're doing here is just saying, if the state's not there yet, set it to 0. Set the key value pair in the dictionary where the state is the key and the value is 0. Then on the next line, whether or not it's a new state or not, we can add 1 to the existing value for that state. And this should give us the state count that we're looking for, as long as we print SC at the end. And there it is, our state count. Now, if you wanted to do an aggregation that, let's say, maybe we wanted to sum up the revenue by state, we could do that pretty easily too. Instead of adding 1 to the value for state, we would be adding the rev value, the floatorized rev value that would sum up the values by state. And you can give that a shot if you'd like to try it. This is what we call an aggregation. We also call it a grouping. The reason we call it a grouping is that we're grouping data that belongs to a particular unique key. Here are 2 New Jersey lines. Here are 2 New York lines and a 3rd New York line. We're basically grouping those lines by a unique key, and then we're either summing or counting based on that key. A dictionary aggregation, while a little bit tricky, is something that you should learn to master because it basically provides a very sophisticated analysis to data when we're using basic Python to analyze.